Hello and welcome back to another video. In this problem, we're asked to prove the statement, the limit as x approaches -3 of 1 minus 4x is equal to 13, using the formal definition of a limit and illustrating with a diagram. So the formal definition of a limit states that the limit as x approaches a of a function f of x is equal to L if for every epsilon greater than 0, any number greater than 0, there is a corresponding delta greater than 0, such that if 0 is less than the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So plugging in our actual values for this problem, that means that 0 is less than the absolute value of x minus a is here -3, is less than delta, and f of x is 1 minus 4x minus L is 13. This is less than epsilon. So here we have 0 is less than x plus 3, absolute value is less than delta, and -4x plus 1 minus 13 is minus 12, is less than epsilon. So the first thing to do is to get rid of this part of the inequality. If the absolute value of x plus 3 is greater than 0, that just means that it's not equal to 0. This is also saying that it's greater than all the negative numbers, but we already know that because any absolute value is greater than the negative numbers, so we can eliminate this and basically say that it's not equal to 0. Therefore, x plus 3 is not equal to 0, and x is not equal to -3. We don't really have to worry about this, though, because we're looking at the limit as x approaches -3, so it's the behavior as the function approaches -3, not actually at -3. So we simply have the absolute value of x plus 3 is less than delta, and the absolute value of -4x minus 12 is less than epsilon. So now what we can do is we can factor out a -4 from this absolute value. So you have to be a little careful here because this is a negative number. And we have to say that this isn't equal to -4 times the absolute value of x plus 3. It's equal to 4 times the absolute value of x plus 3. Right? Pulling out the negative, bringing it outside, we have to make it positive. Why? Well, we basically have to take the separate absolute value of these two things and then multiply them together to keep, because this is positive, so this has to be positive. So this is less than epsilon. Dividing by 4, with the absolute value of x plus 3 is less than epsilon over 4. If the absolute value of x plus 3 is less than delta and it's less than epsilon over 4, therefore delta equals epsilon over 4. So for any positive epsilon that we choose, there's going to be an equivalent delta, which is just that value, epsilon divided by 4. We have to prove this by taking our function, or our inequality right here, and saying, okay, x plus 3 is less than delta, therefore it's less than epsilon over 4. We can then multiply both sides by 4, and to say, okay, epsilon is greater than 4 times x is 4x, 4 times 3 is 12. And then we just have to multiply both sides by the absolute value of -1. Absolute value of -1 is just 1, so this is epsilon times 1, which is just epsilon. Distributing this into the absolute value, however, we get -4x minus 12. This is equal to -4x minus 13 plus 1. This is therefore equal to 1 minus 4x minus 13, which is f of x minus L. Therefore, with our given relationship, we can prove that f of x minus L must be less than epsilon. So now that we've proved it, we're going to use it for a diagram. So if we have this function, and it looks a little something like this. we're saying that as x approaches -3, the value of the function approaches 13. And if we go delta away from -3, so subtracting delta from it, adding delta from it, we'll get equivalent y values that are associated with this function, and these y values will be epsilon away from 13. And for all of the x values that you plug in, all of the y values will be within this range for any given epsilon.